They shine brighter than thousands of galaxies combined, and yet they remain a mystery. This audiobook accompanies you for 2 hours on a journey through quasars, the most powerful beacons in the universe. Objects so distant that they show us the remote past of the cosmos, and so extreme that they challenge our understanding. What are they really? How can they generate so much energy from such a small point? A relaxing tour of one of the most astonishing phenomena in space, where each piece of information illuminates a secret of the deep universe. At its core, a quasar is an extremely bright galactic nucleus, powered by a supermassive black hole that devours matter. This process generates a colossal amount of energy, equivalent to the output of thousands of stars. Imagine a campfire emitting light so intense that it can be seen from billions of light years away. That is the magnitude of the energy produced by quasars. But how can we see something so distant? The answer lies in light. Quasars emit radiation across various wavelengths, from radio to X-rays, allowing us to detect them with powerful telescopes. The story of the discovery of quasars is as intriguing as the objects themselves. In the 1960s, astronomers were perplexed by a series of celestial objects that did not fit into known categories. They were radio sources that seemed to be at incredible distances. What were they? Were they sending messages from another galaxy? Over time, they realized they were quasars, and that completely changed our understanding of the universe. But how do quasars differ from normal galaxies? While a galaxy can be home to billions of stars, a quasar is the manifestation of a black hole devouring matter at a frantic pace. It's like comparing a quiet city to a shining lighthouse in the midst of darkness. The energy of a quasar is so intense that it surpasses that of most other objects in the universe. The process that generates this energy is an impressive physical spectacle. When the black hole attracts matter, it heats up to extreme temperatures before being consumed, releasing energy in the form of light and radiation. It's a cosmic dance of forces where gravity and matter combine to create one of the greatest wonders of the universe. But why is it important to understand how quasars work? The relationship between quasars and supermassive black holes at the centers of galaxies is fundamental to understanding the evolution of the universe. Every time we observe a quasar, we are looking back in time to when the universe was still young. It's as if quasars are windows into the history of galaxy formation. Each one tells us a story about the life and death of the great black holes that feed them. Quasars are not a unique phenomenon. There are several types, each with distinct characteristics. Some are brighter in radio, while others are optically intense. This classification is essential for astronomers as it allows them to categorize and study these celestial bodies more effectively. But what do these differences mean for our understanding of the cosmos? The influence of quasars on galaxy formation is another crucial aspect. As quasars emit energy, they can affect the surrounding environment, influencing the formation of new stars and galaxies. Thus, quasars are not only beacons of light, but also agents of change in the vast universe. This leads us to wonder, how have they truly shaped the structure of what we know today? The role of quasars in the context of the universe is immense. They are located at such great distances that their light has traveled billions of years to reach us. This means we observe the universe as it was in the past, providing essential clues about its evolution and expansion. How do these distant bodies relate to the history of the universe and its future? Quasars also play an important role in the epoch of reionization, a crucial period in the history of the universe. During this phase, the radiation emitted by quasars helped ionize the hydrogen in space, allowing light to travel more freely. Understanding this process offers us a clearer view of how the first stars and galaxies began to form. But what other secrets can quasars reveal about the early universe? Observing quasars is a complex task that requires advanced technologies. The most powerful telescopes in the world have been designed to capture the faint and distant light of these objects. Each new discovery brings us one step closer to unraveling the mysteries of the universe. What new wonders might be waiting to be discovered in the cosmos? The light emitted by quasars is not only impressive in terms of intensity, it also contains vital information. By analyzing their spectra, scientists can learn about the composition of the universe, dark matter, and dark energy. Each flash of light is like a message that tells us about the history of the cosmos. Finally, the expansion of the universe is another aspect intertwined with the study of quasars. These objects help us understand how the universe is expanding and how it has changed over time. As we continue to explore and learn about quasars, we find ourselves on the frontier of discoveries that could redefine what we know about the universe. In summary, quasars are much more than mere points of light in the sky. They are guiding lights that illuminate our quest for knowledge about the cosmos. They teach us about the history of the universe, the nature of black holes, and the evolution of galaxies. As we delve into the fascinating world of quasars, we embark on an endless journey toward understanding the vast and mysterious universe we inhabit. Have you ever looked up at the sky and felt small in the vastness of the universe? In that vast ocean of stars, there are objects that shine with astonishing intensity, quasars, but what are they really? To understand this, we first need to break down their name. The word quasar comes from quasi-stellar object, which translates to almost stellar object. This is because when they were discovered, astronomers thought they were very distant stars due to their brightness. However, what they really are some of the most powerful structures we know of. Imagine a giant flashlight in the darkness of a moonless night. That flashlight is what you might think of as a quasar, but instead of being a simple beam of light, these objects are like cosmic beacons that emit energy in unimaginable magnitudes. Where does that energy come from? That's where it gets really fascinating. Quasars are the result of supermassive black holes at the centers of galaxies that are devouring matter. This process generates colossal amounts of energy, which manifests as visible light and other radiations. At their core, a quasar tells us a story about the young universe. Its light can travel billions of years to reach us, meaning we see the past. But how exactly do these titans of light form? The matter falling into the black hole doesn't go directly in. Instead, it forms a rotating disk known as an accretion disk. This disk heats up to extreme temperatures, generating luminosity that can surpass that of thousands of galaxies combined. Imagine millions of stars accumulating in a single point, shining with a glow so strong that it can be seen across unimaginable distances. Quasars are incredibly distant, making them windows into the past of the universe. When we observe a quasar, we don't just see light. We are also witnessing the process of galactic structure formation. But what about their difference from normal galaxies? The key lies in their activity. While many galaxies are calm and serene, quasars are like rebellious teenagers, full of energy and activity. Their intense light and erratic behavior make them unique in the universe. The story of quasars is not just scientific, but also a journey of discovery. In the 1960s, astronomers began to notice that some objects in the sky did not behave like known stars or galaxies. Over time, they realized that these objects were something completely new. They were not only extremely bright, but also located at such distant points that they offered us a glimpse of the universe in its earliest stages. As we advance in our understanding, we also begin to see the connections. Quasars and supermassive black holes are intimately related. Each quasar we observe is indicative of a black hole in action, devouring matter and shooting energy into space. It's like a cosmic dance where the black hole and the matter formed around it interact in complex ways, creating phenomena that challenge our understanding. It's interesting to note that not all quasars are the same. There are different types, such as radio-loud quasars, which emit radio waves, and optically bright quasars, which are more visible in the spectrum of light that our eyes can perceive. This diversity helps us better understand the complexity of the universe and how each quasar behaves uniquely, depending on its environment and the conditions in which it formed. When we think about galaxy formation, quasars play a crucial role. They are like architects in the construction of galactic structures. The heat and energy they emit can influence the surrounding gas and dust, accelerating the formation of new stars and, consequently, new galaxies. This leads us to reflect on how the energy of a quasar can have repercussions in the creation of new forms of life in the cosmos. In the context of the universe, quasars are like beacons guiding us through the darkness of space. They help us map the expansion of the universe and understand how it has developed over billions of years. Each observation of a quasar gives us more information about the structure of the cosmos and how galaxies are organized into large groups and clusters. The light emitted by a quasar is more than just brightness. It is a message from times past. Through this light, scientists can infer the composition of the universe and how it has changed. By studying the light from quasars, we can learn about the distribution of matter in space and how it has evolved throughout history. Finally, quasars are not only a topic of study in modern astronomy, but have also captured the imagination of many. Their representation in popular culture, from movies to books, shows us how these cosmic phenomena have influenced our perception of the universe. Ultimately, quasars are a reminder of how small we are and how vast the cosmos surrounding us is. So the next time you look up at the starry sky, remember that some of those bright points could be quasars, sending their light through time and space, telling us stories that have been waiting to be heard for eons. Quasars are, in essence, the beacons that illuminate our path in the quest for truth about the universe. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Since the 1960s, astronomers began to observe a strange phenomenon in the sky, an intense and mysterious glow that defied all logic. What was it? The answer was a true puzzle in the world of astronomy. Quasars. These cosmic objects, which appear as distant stars, are actually beacons of energy found at the heart of distant galaxies. But how were these titans of the universe discovered? The first quasar was identified in 1963 by astronomer Martin Schmidt. While observing an object that emitted radiation at wavelengths never seen before, Schmidt realized that it was something extraordinary. Its initial name was quasi-stellar radio source, but why was it called that? The answer lies in its appearance. They looked like stars, but their behavior was vastly different. As the study deepened, it became clear that these objects were actually much brighter than any known star. In the context of the 1960s, the discovery of quasars was revolutionary. The scientific community was accustomed to studying celestial objects that were relatively close, but quasars, as mentioned, were located billions of light years away, making them true messengers from the past. Every beam of light we see today from a quasar has traveled through the cosmos for billions of years, offering us a window into the primitive universe. As more data was collected, other quasars were identified, each with unique characteristics. The question that arose was, how could they be so bright? The answer lies in their nature. Quasars are powered by supermassive black holes located at the center of their respective galaxies. When matter, such as gas and dust, approaches these black holes, it forms an accretion disk. As the matter spirals toward the black hole, it heats up to extreme temperatures, emitting radiation in the form of light and other wavelengths, giving them that unmatched brightness. Over time, researchers realized that quasars were not just astronomical curiosities, but played a crucial role in the evolution of galaxies. How is that possible? When a quasar shines brightly, its energy can influence the environment of its galaxy, affecting the formation of new stars and even the structure of the galaxy itself. This phenomenon is known as feedback, where the energy from the quasar can heat the surrounding gas, preventing it from condensing and forming new stars. But what about the history behind the research of quasars? For decades, astronomers have faced challenges in trying to unravel the mysteries they hold. Initial observations focused on searching for patterns and understanding detection methods. Technological advancements such as radio telescopes and optical telescopes have allowed scientists to observe and study quasars with greater precision. As technology has advanced, so has our understanding of these fascinating objects. The scientific community has made great efforts to classify quasars. Some are distinguished by their brightness in radio waves, while others are more prominent in the optical spectrum. This classification has led to new questions. What determines the type of a quasar? Why are some brighter than others? Through meticulous studies, astronomers have concluded that factors such as the mass of the black hole, the amount of material available to feed it, and the inclination of the accretion disk influence these differences. An intriguing aspect of quasars is that they are not all the same. Some are found in galaxies that are in the process of colliding, which can trigger an increase in quasar activity. This interaction can be compared to the merging of two rivers, where the current accelerates and becomes more turbulent. Thus, quasars not only provide insight into black holes and star formation, but also reveal the dynamic and often chaotic behavior of the universe. The story of the discovery of quasars speaks not only of science but also of human curiosity. Each new observation opens the door to a universe of questions. What else can we learn from these bright objects? What secrets do they still hide from us? With each advancement, the exploration of quasars brings us closer to understanding not only the past of the universe but also the future of cosmology. As we look up at the sky and contemplate the vastness of the cosmos, let us remember that each star, each quasar, is an ancient story speaking to us from time. As we continue to investigate, quasars will remain beacons of knowledge, illuminating our path toward a deeper understanding of the nature of the universe. What other mysteries will be revealed along the way? Only time and our curiosity will tell. Quasars are some of the most fascinating objects in the universe, but what makes them so special compared to other galaxies? To answer this question, we first need to understand what quasars are and how they differ from the galaxies we know. Essentially, quasars are extremely bright cores of galaxies that host supermassive black holes. But why are they so luminous? The answer lies in their energy. Think of a lighthouse on the coast. This lighthouse emits powerful light to guide ships. Even on the darkest nights, quasars work in a similar way, but their light comes from the enormous energy released when material falls into a supermassive black hole. This process of attracting matter generates heat and radiation, resulting in impressive luminosity. Thus, a quasar can shine brighter than thousands of galaxies combined. However, their nature is not limited to being just a source of light. So, how do quasars really differ from normal galaxies? Imagine galaxies as cities. In a quiet city, life can flow serenely, with daily activities and a relatively stable environment. In contrast, a quasar is like a bustling metropolis full of activity and energy. A normal galaxy may contain stars, planets, and gas, but a quasar is in an active growth phase where its black hole is devouring matter at a frantic pace. This activity unleashes a cascade of energy that transforms the quasar into one of the brightest objects in the cosmos. Moreover, we must consider the variability of quasars. Sometimes they can appear brighter or darker. This is like a city that lights up more during a festival or dims during calm times. This variability is one of the characteristics that astronomers study to better understand these distant objects. The brightness of a quasar can change within days or weeks, indicating that the processes occurring near the black hole are extremely dynamic. One fascinating aspect is that quasars can be observed at incredibly large distances. This means we are seeing light that has traveled millions of light years to reach us. Imagine being on a beach and watching the ocean waves, but instead of water, they are flashes of light telling us the story of the early universe. Each flash from a quasar is like an echo of its past, revealing information about galaxy formation and the evolution of the cosmos. Quasars also offer us a unique insight into how galaxies behave in the universe. While a galaxy may be relatively stable, a quasar is in a constant state of transformation. This raises intriguing questions. How do quasars affect their surroundings? Do they influence the growth of other galaxies? As a quasar consumes matter, it can release energy that impacts star formation and the dynamics of its host galaxy. In terms of size, a quasar can be more than 1,000 times larger than our Milky Way. Can you imagine an object so massive and bright that it could eclipse everything we know? This immensity is one of the reasons why quasars are so captivating to astronomers. Each one is like a beacon that not only illuminates its surroundings but also helps us understand the history of the universe. The distance at which quasars are found is also significant. Generally, quasars are located at the heart of distant galaxies, meaning we are looking back in time. This allows us to study what galaxies were like in the very early epochs of the universe. What do these objects teach us about the formation of cosmic structures? Quasars may be key to answering some of the deepest questions about the origin of the universe. The light from quasars is also special. Not only is it intense, but it contains information about the composition of elements in the universe. Each type of light emitted by a quasar can reveal details about the temperature, density, and velocity of the materials surrounding it. It's as if the quasar is sending a coded message through space, a message that scientists are trying to decipher. As we advance in our understanding of quasars, we face new challenges and questions. What else will they reveal about the role of black holes in galaxy formation? How does their energy influence the development of the universe? Each discovery about quasars brings us one step closer to understanding the complexity of the cosmos. In conclusion, quasars are not just bright astronomical phenomena. They are windows into the history of the universe. Their energy, dynamics, and relationship with galaxies are topics that continue to amaze scientists and cosmic enthusiasts alike. As we keep exploring and observing these beacons of the universe, each new discovery invites us to reflect on our place in the vast and mysterious cosmos. The immense energy emitted by quasars has fascinated astronomers since their discovery. But how is it possible for such a small object compared to the vast universe to shine with such intensity? To understand this, we must first delve into the heart of these cosmic giants. Quasars are essentially the cores of galaxies that harbor supermassive black holes. When matter approaches these black holes, an accretion disk forms, a kind of whirlwind of gas and dust that spins at high speed. Why is this so important? As matter slides toward the black hole, it heats up to extremely high temperatures. Imagine intense friction, similar to when you rub your hands together quickly. The result is heat. In the case of quasars, that heat translates into energy released in the form of light and radiation. But what is the magnitude of this energy? To put it in perspective, a single quasar can emit more energy than thousands of galaxies combined. Isn't it amazing to think that there are lights in the universe that can eclipse so many stars? This phenomenon allows them to be visible even billions of light years away. In a sense, quasars are cosmic beacons that guide us through the darkness of space. The energy of a quasar is not limited to visible light. It also includes X-rays and radio waves. Can you imagine having a lighthouse that not only shines but also emits signals at different frequencies? This allows scientists to study quasars from multiple angles, thus gaining a more comprehensive understanding of these fascinating objects. Each type of radiation offers clues about what is happening at the heart of the quasar and the matter surrounding it. The interaction between the black hole and the material enveloping it is fundamental to understanding how this energy is generated. When matter falls into the black hole, it accelerates and compresses, resulting in a colossal release of energy. This process is so efficient that, in comparison, nuclear fusion in stars, which is the most common energy source in our universe, turns out to be quite weak. It's as if a quasar is using a battery of infinite energy compared to the limited capacity of a star. The energy released by quasars also plays a crucial role in the evolution of galaxies. When a quasar becomes active, its radiation can influence the formation of new stars in its host galaxy. But how does this happen? The intense radiation can heat the surrounding gas and expel it, thus limiting the formation of new stars. This process, known as feedback, is vital for understanding how galaxies change and evolve over time. Moreover, the energy of quasars not only affects their galaxy but can also impact their galactic environment. Imagine a quasar as a powerful storm sending shockwaves around it. These waves can compress gas clouds in other parts of space, which in turn can lead to the formation of new stars in regions that were previously inactive. It is a cosmic dance of creation and destruction, where the energy of a quasar can be the catalyst for new generations of stars. Interestingly, the study of quasar energy also helps us better understand the expansion of the universe. By observing how the light from a quasar shifts to the red, scientists can infer information about the speed at which they are moving away from us. This phenomenon, known as redshift, is fundamental to modern cosmology. Quasars act as beacons that illuminate the path to understanding the history of the universe. It is fascinating to think that despite the distance separating us from quasars, their energy allows us to access information about the early moments of the universe. Every time we observe a quasar, we are looking back in time, sometimes billions of years, almost as if we are watching a movie of cosmic history. Finally, the energy of quasars raises intriguing questions about the limits of the universe and dark matter. How are these bright objects related to the mysteries we have yet to solve? As scientists continue to investigate, quasars will remain a key to unraveling the secrets of the cosmos. The energy of a quasar is much more than just a simple bright light. It is a complex phenomenon that offers us a window into the past, present, and future of the universe. Through its study, we not only learn about these impressive objects, but also expand our understanding of the very nature of space and time. So the next time you think of a quasar, remember that you are looking at a true cosmic titan whose stories and secrets are still waiting to be discovered. Did you know that quasars are intimately related to one of the most enigmatic objects in the universe, supermassive black holes? These colossi are found at the center of many galaxies, and their influence is fundamental in the formation and behavior of quasars. But what exactly is the connection between a quasar and a supermassive black hole? The answer involves a journey through the physics of the cosmos. Quasars are extraordinary sources of light and energy, and their brightness is due to the matter swirling and sliding into a supermassive black hole. Imagine a huge whirlpool in water. When the water moves rapidly toward the center, a vortex forms that can be very powerful. Something similar happens in the accretion disk of a black hole, where the falling material generates an immense amount of energy. This process is what makes quasars shine intensely. Now, what is a supermassive black hole? These cosmic giants can have millions or even billions of times the mass of the Sun. Their gravity is so strong that nothing can escape from them, not even light. However, despite their dark nature, when a black hole is surrounded by material falling into it, it becomes a bright beacon in the universe, and that is what we observe as a quasar. But how does a quasar form? In the heart of a growing galaxy, the black hole begins to attract gas and dust from its surroundings. This material does not fall directly into the black hole, but forms a rotating disk around it, somewhat like the rings of Saturn. As the material accelerates and compresses, it heats up and emits radiation in the form of light and other wavelengths. This process of accumulation and emission is what turns a black hole into a quasar visible billions of light years away. The relationship between quasars and black holes does not end there. The activity of a quasar can influence the evolution of its host galaxy. Imagine a quasar as a lighthouse that not only illuminates the way, but could also be shaping the landscape around it. By releasing enormous amounts of energy, quasars can heat the gas in their galaxy and affect the formation of new stars. This can unleash a series of events that change the structure and destiny of the entire galaxy. Moreover, quasars can serve as tools for studying the universe. By observing the light from a quasar, astronomers can learn about the intergalactic medium between us and the quasar. This medium can affect light in surprising ways, and by analyzing these alterations, scientists gain insights into the composition and evolution of the universe. In this sense, quasars are like cosmic messengers telling us stories about the matter and energy that inhabit the spaces between galaxies. You may wonder if all supermassive black holes become quasars. The answer is no. Only those that are in active phases of material accumulation shine like quasars. A black hole can go through long periods of inactivity. during which it does not attract enough material to generate that intense light. It is a cycle where the activity of a quasar can vary over time, making some black holes visible only at certain times in their life. And what about the different types of quasars? Not all quasars are the same. Some are brighter and emit more radiation in radio frequencies, while others are optically bright. This variability is due to factors such as the amount of material surrounding the black hole and the orientation of its accretion disk. Just as stars in the sky can shine in different ways, quasars also have their own unique characteristics. The relationship between quasars and black holes is not only fascinating from a scientific point of view, but it also raises questions about the very nature of the universe. How do these giants affect galaxy formation? What role do they play in the expansion of the cosmos? These questions are essential for our understanding of modern cosmology. Finally, let us not forget that quasars are phenomena that connect us to the past of the universe. Because the light from a quasar can take billions of years to reach us, when we observe a quasar, we are seeing how the universe was at a much earlier time. This provides us with a unique window to explore cosmic history and better understand how our reality has developed. So the next time you think of a quasar, remember that they are not just bright lights in the darkness of space, but also bearers of secrets about supermassive black holes and the vast universe we inhabit. The connection between quasars and black holes is one of the most intriguing stories in astronomy, and their study continues to reveal new mysteries about the cosmos. Let's imagine a vast cosmic ocean filled with twinkling lights that resemble beacons in the darkness. Within this ocean we find quasars, but did you know that not all quasars are the same? There are different types, each with its fascinating peculiarities. Today we will explore the various classifications of quasars and discover what makes them unique. Let's start with quasars. This term refers to a broad category that includes all those bright objects we observe in the universe. However, within this general category, there are different types that stand out due to their specific characteristics. For example, we have radioluminous quasars. What makes them so special? The answer lies in their ability to emit radio waves much more intensely than other quasars. This is because they have powerful jets of particles that are launched at speeds close to the speed of light. Imagine them as enormous cosmic cannons shooting material into space at an incredible velocity. On the other hand, we also find optically bright quasars. These are the ones that shine intensely in the visible light spectrum. Think of them as the rock stars of the universe, attracting the attention of astronomers and enthusiasts alike. Their light is so powerful that it can be seen billions of light years away, allowing us to glimpse the past of the universe. But what about their origin? These quasars are fed by supermassive black holes, which devour material and, in doing so, generate a tremendous amount of energy. However, it doesn't stop there. There is a more intriguing category, high redshift quasars. These are the ones located at great distances from Earth, meaning we are seeing their light as it was in the past when the universe was much younger. Imagine time as a river and we are looking back at its flow. These quasars offer us a unique window into the history of the cosmos, allowing us to study how the first galaxies formed. When looking at these different types of quasars, an interesting question arises. How do we know what type of quasar we are observing? Astronomers use spectroscopy, a technique that breaks down light into its components. This way, they can see the fingerprints of the elements present in the light emitted by the quasar, allowing them to identify its classification. It's like being a cosmic detective, searching for clues in the light to solve the mystery of these distant objects. Moreover, variability is another key characteristic. Some quasars can change their brightness over short periods, while others are more constant. This is because quasars are not static entities. They are in constant evolution. The variability in their brightness can provide clues about the dynamics of the supermassive black holes at their centers. Imagine a lighthouse that turns its light on and off, revealing the secrets of its inner workings. Some quasars also have features that challenge our expectations. For example, there are quasars that exhibit complex structures in their emissions. suggesting that there is more at play than we initially thought. These quasars are like the artworks of the universe, each with its own story and characteristics to tell. The diversity of quasars is not only fascinating in itself, but it also helps us better understand the universe. Each type of quasar provides valuable information about the formation and evolution of galaxies, as well as the nature of dark matter and dark energy. It's like a cosmic puzzle where each piece is a quasar, and by putting them together we get a clearer picture of the structure of the universe. However, the classification of quasars is not static. As we advance in research, we are likely to discover new categories or redefine existing ones. Technological advancements such as more powerful telescopes and more sophisticated observation techniques are providing us with information that challenges our preconceived notions. Each new discovery adds a layer of complexity to our understanding of these extraordinary objects. In summary, quasars are much more than just bright lights in the sky. They are complex and varied entities that offer us a glimpse into the inner workings of the universe. From radioluminous quasars to optically bright ones, each type has its own story to tell. As we continue to explore and discover more about these cosmic beacons, the universe becomes increasingly fascinating and full of mystery. The journey has just begun, and each new investigation promises surprising revelations about the nature of the cosmos and our place within it. What role do quasars play in the formation and evolution of galaxies? To understand this, it is first essential to imagine a large dance hall in the darkness of space. In this hall, quasars are like strobe lights shining brightly, while galaxies are the dancers swirling around them. These lights not only illuminate the environment but also influence the movement of the dancers, affecting their dance and shape. Quasars, being such powerful sources of energy, act as catalysts in the evolution of galaxies. When a quasar shines, it emits enormous amounts of radiation that can have significant effects on its surroundings. Imagine that each beam of light it emits is like a breath of air pushing nearby galaxies. This push can cause these galaxies to merge, separate, or change shape, thus affecting their development over time. But how exactly do these powerful cosmic beacons influence their surroundings? One of the most interesting ways is through the radiation they emit. This radiation not only lights up space but also heats the gas and dust found nearby. Think of a campfire. If you get too close, the heat will make you move. Similarly, quasars heat the gas in their vicinity, which can destabilize it and lead to the formation of new stellar material. Thus, quasars not only shine, but are engines of creation in the universe. As galaxies approach a quasar, they become enveloped in its light and energy, which can intensify their activity. This is comparable to a plant growing faster when exposed to intense sunlight. In this sense, quasars can be seen as lighthouses guiding the growth of new stars in nearby galaxies, thereby fostering diversity and evolution in the cosmos. However, not all quasars have the same effect. Some may be more like a gentle beacon guiding slowly, while others are explosive, causing significant changes in their surroundings. This variability leads us to wonder, what determines the strength of a quasar? The answer lies in the amount of matter being consumed by the supermassive black hole at its center. The more matter there is, the more energy is generated, and therefore the greater its influence on neighboring galaxies. As a quasar consumes matter, it emits jets of highly energetic particles that can extend through space. These jets are like fireworks exploding in the sky, illuminating everything around them. These events are not only spectacular, but can also reach enormous distances, affecting galaxies that are millions of light years away. Imagine the effect of thunder in a storm. Its reverberating sound can be heard from great distances, altering the environment. What happens when a quasar is in a phase of inactivity, although its light may temporarily fade? Its impact on galaxies does not disappear. The structures formed during its active phase can continue to influence galactic development for millions of years. This suggests that the footprint of a quasar can have a long-term impact, long after its light has gone out. In the context of galaxy formation, quasars also play a crucial role in regulating the amount of gas available for the formation of new stars. This is akin to how a gardener controls water and light for healthy plant growth. If a quasar emits too much radiation, it can heat the gas to such an extent that it prevents its collapse and star formation, while moderate radiation can allow for the growth of new stars. Moreover, the interaction between quasars and galaxies can lead to fascinating phenomena, such as the creation of galactic structures in the form of filaments. These filaments can resemble the branches of a tree, where each branch represents a galaxy influenced by the presence of a quasar nearby. This pattern of structural growth is a testament to the power of quasars in orchestrating the cosmos. And what about quasars that are in the process of merging with other galaxies? This phenomenon can further intensify their activity, unleashing a wave of star formation. Imagine two rivers meeting. The water swirls and mixes in such a way that it creates a powerful torrent. Thus, quasars can become engines of change in the universe, guiding the evolution of galaxies into new forms and structures. Finally, it is fascinating to think about how quasars, through their interactions with galaxies, may have played a role in the formation of our own Milky Way. Since the first steps in the creation of the universe billions of years ago, quasars have been a thread in the cosmic history, illuminating the path of galactic evolution. The next time you look up at the starry sky, remember that those twinkling lights are more than just simple bright points. They are cosmic beacons that have influenced the dance of galaxies over time, shaping the structure of the universe as we know it. In this vast stage, quasars remain key players, and their story is far from over. Quasars, those mysterious and brilliant sources of energy in the universe, are not only fascinating for their immense luminosity, but also for their location. Where exactly are they found? To understand their place in the vast cosmos, it is important to consider their relationship with the galaxies that host them and their role in the evolution of the universe. When we talk about quasars, we refer to celestial objects located at the center of distant galaxies. But what does this mean in terms of distance and time? Imagine you are looking at a star in the sky. What you are really observing is light that has traveled for millions of years to reach your eyes. In the case of quasars, this light may have traveled billions of years, meaning we are seeing the universe as it was in its infancy. It's like looking into the past, a journey through time that allows us to understand what the universe was like when it was still forming. Quasars are like beacons in the darkness of space, illuminating the way to the earliest moments of our cosmic existence. But what do they tell us about the universe? By observing quasars, astronomers can gain valuable information about the nature of matter and energy in the cosmos. These bright objects are indicators of activity in their host galaxies. In other words, a quasar can tell us about the history of the galaxy in which it resides, its formation processes, and its interactions with other celestial bodies. One of the most intriguing features of quasars is their relationship with supermassive black holes. At the heart of each quasar lies a black hole that devours matter at an astonishing rate. But how does this connection form? Imagine the black hole as a giant magnet, attracting everything around it. As matter rushes toward the black hole, it heats up and emits a tremendous amount of energy, producing the brilliant light we see from Earth. This process not only illuminates the quasar, but also affects the galaxy as a whole, shaping its evolution. Quasars are, therefore, a reflection of galactic activity. But why are they so important in the context of the universe? These objects are witnesses to cosmic history. They show us how galaxies grew and developed over time. By studying their light and behavior, astronomers can reconstruct the narrative of the universe, from its formation to the present day. It's like reading a book where each chapter reveals a new aspect of the history of the cosmos. By observing the distribution of quasars in the universe, we can also learn about their formation and their relationship with dark matter. What is the role of this mysterious substance in the cosmos? Dark matter is something we cannot see directly, but its influence is undeniable. By analyzing where quasars are located, scientists can infer the structure of the universe and how dark matter shapes everything around it. It's like trying to piece together a puzzle without having all the pieces, but each quasar we find helps us understand a little more of the complete picture. As the universe expands, quasars also help us understand this phenomenon. The light they emit is affected by the expanding space, providing us with clues about the speed and direction in which the universe is moving. It's a reminder that everything in the cosmos is in constant change and evolution. And quasars are beacons guiding us in this exploration. The location of quasars also highlights their importance in cosmology. They are found in regions where galactic activity is intense, suggesting that they are linked to the processes of galaxy formation. What does this mean for our understanding of the cosmos? It indicates that quasars are indicators of the universe's vitality, functioning as markers on a cosmic map that reveals the history of galaxy creation and larger structures. Observations of quasars have also revealed that there is more at play than just the light they emit. They are surrounded by clouds of gas and dust that can influence their brightness and color. This dynamic environment is a crucial part of the quasar story, as it affects how we see these objects from Earth. Each flash of light we receive is a window into a complex and ever-changing world. Moreover, quasars are essential for understanding the epoch of reionization, a period in the history of the universe when the light from the first stars and galaxies caused hydrogen in space to ionize. By studying quasars from this era, scientists can unravel the mysteries of how the first structures in the universe formed. As technology advances, the methods for observing quasars also evolve. More powerful telescopes and innovative techniques allow astronomers to capture more details about these distant objects. Each new discovery about quasars not only adds pieces to the cosmic puzzle, but also opens new questions about how the universe works. The study of quasars leads us to understand that, although they are located billions of light years away, their influence reaches us here on Earth. They remind us that we are part of a vast universe, interconnected with the phenomena occurring in the farthest corners of space. Thus, the exploration of quasars is not just a journey into the unknown, but also a reflection on our own existence in the cosmos. Quasars, then, are much more than bright objects in the sky. They are beacons illuminating our path toward understanding the universe, revealing the history of matter, energy, and the evolution of galaxies. As we continue our quest for knowledge, quasars will remain an inexhaustible source of wonders and fascinating discoveries. When we look at the night sky, one of the questions that arises is, how could the first stars and galaxies form in a universe that, in its early moments, was such a chaotic place? In this context, quasars play a crucial role, as they are like beacons in the darkness of space, illuminating the path toward understanding the history of the cosmos. But why are they so important for the reionization of the universe? To understand this, it is essential to first think about what happened shortly after the Big Bang. At that moment, the universe was filled with a dense fog of particles and radiation. Over time, this fog began to cool, and electrons and protons combined to form hydrogen atoms. However, the universe did not become transparent immediately. It was only when the first stars began to shine that this situation changed. What did those stars do? They generated light and heat, breaking the fog that had been obscuring the cosmos. At this point, quasars enter the story. Quasars are extremely luminous and are believed to be powered by supermassive black holes. When these black holes devour matter, they release enormous amounts of energy in the form of light. This process not only illuminates the cosmos, but also has a significant effect on the environment surrounding them. Can you imagine how much light a quasar can emit? Its brightness can surpass that of thousands of combined galaxies. When a quasar shines, it emits radiation that can ionize the hydrogen in its neighborhood. This ionization is essential for reionization, as it allows electrons and protons to separate again. In other words, quasars acted as gigantic beacons, illuminating and heating the universe, allowing it to become more transparent. But how does this relate to the formation of the first galaxies? The light from quasars not only helps to clear away the hydrogen fog, but also influences how other cosmic structures group together. Thus, as the universe cleared, galaxies began to form and cluster, creating a more complex structure. Quasars, being indicators of activity in the early cosmos, allow us to study how these groupings of galaxies evolved over time. Now, how common were quasars during the reionization era? They are estimated to have peaked about 11 billion years ago, when the universe was only a third of its current age. At that time, quasars were more abundant and, thanks to their intense light, played a crucial role in transforming the cosmic environment. By studying these distant objects, astronomers can gain insights into what the universe was like in its early days. An intriguing question is, could we have seen a quasar in the past? If we had a time machine, we could travel to that era and observe how these cosmic beacons illuminated the darkness of space. Their light, which has traveled billions of years to reach us, offers a unique window into the past. Quasars also provide valuable information about the composition of the universe and the conditions that surrounded it in its early stages. By analyzing the light they emit, scientists can determine the amount of elements and compounds present in the primitive universe. This not only helps us better understand the chemistry of the cosmos, but also gives us clues about the evolution of stars and galaxies. Moreover, the relationship between quasars and galaxies does not stop at the moment of reionization. Quasars can influence the formation and growth of galaxies throughout the history of the universe. Their intense radiation can affect the surrounding gas, thereby regulating the rate of star formation and galactic growth. This introduces a new dimension to our understanding of how the universe developed. And what about quasars today? Although most of them are located billions of light years away, their study remains relevant. They help us understand not only the past, but also the future of the universe. As scientists continue to investigate, quasars may provide clues about dark matter and dark energy, two of the most enigmatic elements of the cosmos. Finally, it is fascinating to think about how quasars, those distant cosmic beacons, have shaped the history of the universe. From reionization to galaxy formation, their impact is profound and lasting. By looking up at the sky and contemplating their light, we are connecting with the past and better understanding our place in this vast and mysterious cosmos. In the journey of science, each discovery about quasars brings us a little closer to unraveling the secrets of the universe. How is it possible to observe objects that are billions of light years away? The answer lies in the observation techniques that astronomers use to study quasars. These distant beacons of the universe are not just bright points in the sky. They offer invaluable information about the nature of the cosmos. The observation of quasars raises fascinating questions. What kind of light do they emit? How do we analyze it? And above all, what secrets do they reveal to us? Quasars emit light across a variety of wavelengths, from radio to X-rays. This light is a mixture of different types of electromagnetic radiation, each of which provides clues about their characteristics and behavior. Visible light, for example, is what our eyes can see, but there are many other forms of light that we cannot perceive. Telescopes are powerful tools that allow us to capture these invisible wavelengths and transform the intangible into information that we can study. An intriguing aspect of the light emitted by quasars is its immense brightness. Some of these light sources are so bright that they outshine entire galaxies. This extraordinary brightness is due to the enormous amount of energy generated by the material falling into the supermassive black hole at the center of the quasar. But how do we know how far away a quasar is just from its light? This is where the concept of redshift comes into play, which is a phenomenon that occurs when light is stretched as the object moves away from us. The farther away a quasar is, the greater the redshift, allowing us to calculate its distance accurately. Technology has advanced impressively, and today we have space telescopes like Hubble and the Chandra X-ray Observatory, which can observe quasars at wavelengths that the Earth's atmosphere blocks. Imagine a telescope that can see beyond what our eyes can capture. That is what these instruments do. Thanks to them, we have been able to identify thousands of quasars and study their properties in great detail. By analyzing the light from a quasar, scientists can identify the chemical composition of its surroundings. This is achieved through a process called spectroscopy, which breaks down light into its different wavelengths. Each chemical element has a unique fingerprint in the spectrum, meaning we can determine what gases and materials surround the quasar just by observing the light it emits. Isn't it fascinating to think that light can act as a kind of message telling us about the components of the universe? Furthermore, the light from quasars is used to study the large-scale structure of the universe. When quasars are aligned with other celestial objects, they can act as gravitational lenses where the gravity of a massive object distorts the light passing near it. This phenomenon allows us to observe objects that would otherwise be invisible and better understand how matter is distributed in the universe. The study of quasar light also raises questions about the evolution of the universe. By observing quasars from different epochs, astronomers can compare their brightness and characteristics to understand how they have changed over time. This process is similar to looking at family photographs over the years. It gives us perspective on how they have grown and evolved. What about the relationship between quasar light and the expansion of the universe? As the universe expands, the light from quasars moving away from us shifts to longer wavelengths, also known as cosmological redshift. This phenomenon not only helps us measure the speed at which quasars are receding, but also provides crucial information about the rate of expansion of the universe. The light from quasars also helps us understand extreme phenomena such as black hole formation and galaxy dynamics. When we observe a quasar, we are not just looking at a distant object. We are witnessing processes that have been occurring for billions of years. It's as if we have a window into the past of the universe. However, observing quasars is not without its challenges. Sometimes the light from a quasar can be affected by dust and gas in space, which can obscure its brightness and complicate its study. Nevertheless, astronomers have learned to overcome these obstacles using different methods and technologies, such as telescopes at different wavelengths and data correction techniques. The future of quasar observation is promising. With the development of more advanced telescopes and space missions, scientists hope to discover even more about these fascinating objects. What new findings await us? Will we be able to unravel the mysteries of dark matter and dark energy through the light of quasars? Only time will tell. In conclusion, the light from quasars not only illuminates the cosmos, but also offers us a profound insight into the history and evolution of the universe. Each flash of light tells a story, and each quasar is a witness to the cosmic events that have shaped our world. The next time you look up at the night sky, think of all the wonders hidden in the light of those distant beacons of the universe. The light from quasars is like a message sent from the depths of the universe, a whisper of energy that travels billions of years to reach us. But what exactly does this light tell us? To answer this question, it is essential to dive into the nature of the radiation emitted by these fascinating celestial objects. Quasars are often referred to as the beacons of the cosmos, and for good reason. Their bright light can be seen at unimaginable distances. Even in the farthest corners of the universe, the light emitted by quasars is extremely intense and in many cases surpasses that of thousands of galaxies combined. This raises an intriguing question. How is it possible for such a small object in relation to its surroundings to produce so much energy? The answer lies in their cores, where supermassive black holes reside. As matter falls toward these black holes, it heats up to unimaginable temperatures, generating radiation in the form of visible light, X-rays and radio waves. Thus, quasars become powerful factories of light. Imagine you are lighting a bonfire. At first, there may not be much fire, but if you keep adding wood and fanning the flames, the bonfire becomes a brilliant spectacle. Similarly, the matter falling toward a black hole increases the brightness of the quasar. This process of accretion is what causes the light of a quasar to be exceptionally bright. But what else can we learn from that light? The light from quasars is not only bright, but also contains valuable information. Through a phenomenon called redshift, scientists can study how light stretches as it travels through space. This redshift is a kind of fingerprint that reveals the speed and direction of the quasar. The farther away the quasar is, the more its light is shifted, indicating that it is in an expanding universe. Thus, the light speaks to us about the history and evolution of the cosmos. By observing the light from quasars, astronomers can identify the chemical composition of the matter surrounding these objects. Did you know that light can be broken down into a spectrum similar to a rainbow? This spectrum reveals the elements present in the region around the quasar. Scientists have found elements such as hydrogen, helium, and heavier metals, suggesting that these quasars are not only sources of light, but also cosmic laboratories where the elements of the universe are formed and distributed. Moreover, the light from quasars has allowed astronomers to study phenomena such as the reionization of the universe. In the early moments after the Big Bang, the universe was filled with ionized matter. As quasars began to shine, they emitted light that helped ionize hydrogen in the cosmos, allowing for the formation of more complex structures. Therefore, the light from quasars not only illuminates but also marks the beginning of galaxy and star formation. However, not everything is so simple. The light from quasars is also influenced by the environment in which it exists. When light travels through clouds of gas and dust, it can be absorbed or scattered, altering its appearance. This is akin to how a lighthouse may look different depending on fog or weather conditions. This interaction is crucial, as it can complicate the interpretation of the data we obtain from quasars. It is also fascinating how the study of quasar light has contributed to our understanding of dark matter. Although we cannot see dark matter, its presence can be detected through the gravitational influence it exerts on light. By analyzing how quasar light bends when passing near massive objects, scientists can infer the distribution of dark matter in the universe. Thus, light becomes a tool for exploring the unknown. Delving deeper into the implications of this light, we find that quasars offer a unique window into the past. Since some of them are so far away, the light we see today is actually a reflection of what was happening billions of years ago. This journey through time allows us to study the evolution of the universe from its earliest stages, providing clues about how the first stars and galaxies formed. The light from quasars has also been instrumental in creating large-scale maps of the universe. By observing a large number of quasars, astronomers can chart the structure of the cosmos, revealing how it is distributed and how different regions relate to one another. This information is crucial for understanding the dynamics of the universe and how it has changed over time. It is astonishing to think about how many questions remain unanswered. Each quasar we observe offers us a new opportunity to learn about the fundamental physics of the universe as technology advances. The tools we use to study quasar light are becoming more sophisticated. With more powerful telescopes and advanced data analysis techniques, the future of quasar research looks promising. Finally, the light from quasars not only fascinates us from a scientific perspective, but also connects us to the vast universe that surrounds us. Each flash of light is a reminder of how small we are in comparison to the immensity of the cosmos. By studying this light, we are not only exploring the universe but also getting to know ourselves. Thus, the light from quasars becomes a beacon of knowledge, guiding us through the mysteries of the universe and revealing the beauty of the unknown. Quasars are not only fascinating for their brightness and power, but they are also vital instruments in our quest to understand the universe. But what do quasars have to do with the expansion of the universe? To answer this question, it is important to first imagine how the universe behaves as a whole. Visualize a balloon being inflated. As it expands, the points on its surface move away from each other. In this analogy, those points represent galaxies, including quasars. When we observe a quasar, we are actually seeing light that has traveled billions of years to reach us. Each flash of light from a quasar contains information about the universe at the moment it was emitted. But why is this so crucial? The light from quasars acts like a kind of beacon that guides us through the cosmos, revealing the history of its evolution and the behavior of space itself. As the universe expands, quasars tell us about its own rate of expansion. This relates to the concept of redshift, which is like the sound effect of a train moving away, where the sound becomes lower in pitch. In the case of quasars, as they move away, their light shifts to longer wavelengths, indicating that the universe is in constant expansion. Interestingly, the energy emitted by quasars is also used to measure distances in the universe. How does this work? Imagine you are in a race and have a stopwatch. If you know the speed at which you are running and how much time has passed, you can calculate the distance you have covered. Similarly, astronomers use the luminosity of quasars to determine how far away they are in the vast universe. But what if I told you that quasars are also like warning lights on a road signaling something larger? In this case, quasars can act as indicators of the presence of dark matter, that mysterious substance that makes up most of the universe but that we cannot see. The light patterns of quasars can reveal how dark matter influences their surroundings, helping scientists build a map of this invisible matter. Some quasars are so far away from us that their light has traveled from times when the universe was very different. What do these ancient quasars tell us? They allow us to look back in time to a primordial universe where matter and energy were in constant flux. This vision helps us understand not only how the universe began, but also how it has evolved into what we know today. The connection between quasars and black holes is also fundamental to understanding the expansion of the universe. Quasars are in essence supermassive black holes that are devouring matter at a frenzied pace. As this happens, they release enormous amounts of energy, allowing them to shine with unimaginable intensity. This process not only affects their own galaxy, but can also influence the dynamics of nearby galaxies, showing how quasars are part of a larger system in the universe. Research on quasars and their relationship to the expansion of the universe does not stop here. As technology advances, scientists are finding new ways to study these cosmic wonders. With more powerful telescopes and advanced observation techniques, we may soon obtain answers to questions that today we can only imagine. What will the next generation of quasars reveal about the nature of space and time? Moreover, observing quasars can also open windows to other cosmic phenomena. For example, when observing how the light from a quasar changes due to the influence of dark matter, scientists can infer the presence of other structures in the universe, such as galaxies and galaxy clusters. In this way, each quasar becomes a piece of the puzzle that helps to understand the expansion of the universe. It is fascinating to think that each quasar we observe is, in a way, a journey through time and space. Its light has traversed vast distances and faced countless obstacles before reaching us. This journey is not only a testament to the tenacity of light, but also a reminder of how interconnected all elements of the universe are. Finally, it is important to reflect on how all these discoveries not only enrich our scientific knowledge, but also invite us to contemplate our place in the cosmos. The quest for answers about quasars and the expansion of the universe is a journey that transcends time and space, a journey that we all share as curious human beings. So when you look up at the night sky and contemplate the stars, remember that each bright point could be a quasar, a window connecting us to the history of the universe and the wonder of the unknown. The exploration of quasars is not only a scientific adventure, but a journey toward understanding who we are and how we fit into the vast and enigmatic universe that surrounds us. Quasars have captured the imagination of astronomers and space enthusiasts alike, and their presence in popular culture is a testament to the awe they inspire. How have these distant and enigmatic objects become part of our stories, movies, and even music? The fascination with quasars is not limited to their scientific nature. They have also inspired artists and storytellers to explore themes of vastness, mystery, and cosmic power. One of the questions that often arises is, how far away are quasars really? The answer is astonishing. Some quasars are so distant that their light has been traveling towards us for billions of years. This luminous journey not only shows us what the universe was like in the past, but also invites us to reflect on our own existence in such a vast and ancient cosmos. This sense of connection to the universe resonates in many works of fiction, where characters seek answers about their place in the world. Science fiction stories often reference quasars as points of light in the darkness of space, serving as beacons that guide intergalactic explorers. Movies and series like Star Trek or Interstellar use concepts of wormholes and travel through quasars to create exciting narratives about exploring the universe. In these stories, quasars represent not only a destination, but also a hope for discoveries and adventures beyond our current understanding. But how do quasars relate to popular culture? A clear example is music. Artists from various genres have referenced these astronomical objects in their lyrics, using the image of a quasar to symbolize light in dark moments or as a metaphor for the search for knowledge and truth. These cultural nods not only showcase the fascination with the cosmos, but also reflect a human desire to explore the unknown. The influence of quasars extends even to visual art. Painters and sculptors have found inspiration in the idea of these cosmic beacons, creating works that capture their mystical essence and the immensity of the universe. Visual interpretations of quasars often evoke feelings of wonder and humility, reminding us that we are just a small part of a vast and complex universe. Within literature, quasars are often used as allegories about life and death, beginnings and endings. Science fiction authors have explored the idea that, like the light of a quasar, our lives can be impactful and bright, even if they are only visible for a brief moment in the vast history of the universe. These narratives offer a unique perspective on the impermanence and beauty of existence. The popularity of quasars can also be seen in education. Books and documentaries for young audiences have introduced new generations to the fascinating world of astronomy through these objects. By presenting quasars as incredible phenomena, interest in science and the exploration of the universe is sparked, inspiring future scientists and astronomers to continue researching. However, the representation of quasars in popular culture is not always scientifically accurate. Sometimes their characteristics are exaggerated, or they are attributed properties they do not possess. This raises an interesting question. Is it important for science and fiction to remain separate, or can fiction be a bridge to understanding complex scientific concepts? The answer to this question may vary, but the connection between science and popular culture is undeniable. As quasars continue to capture the attention of the masses, their relevance in popular culture shows no signs of diminishing. Each new discovery about these cosmic objects fuels people's curiosity and imagination, leading to more works of art, songs, and stories that explore what it means to live in such a vast universe. Moreover, the fact that quasars are some of the brightest and most distant objects we can observe reminds us that there is always more to discover. Every time a new quasar is identified, the door opens to new questions and stories that lead us to explore the limits of human knowledge. This constant discovery is what keeps curiosity alive and the desire to understand our place in the cosmos. In summary, quasars are not just objects of study in the field of astronomy. They are symbols of the human quest for knowledge and connection. Their presence in popular culture reflects a universal desire to explore, understand, and find meaning amid the immensity of the universe. And although they may be distant and mysterious, their light continues to illuminate the minds and hearts of those who look to the sky, inspiring new generations to dream of the stars. The next time you see a reference to a quasar in a movie or a song, remember that it is not just an astronomical phenomenon, but a beacon of human curiosity that continues to shine in the darkness of space. Quasars are one of the most fascinating phenomena in the universe, and in this section we will explore their relationship with an even deeper mystery, dark matter. But what is dark matter really? To understand it, we must think of the universe as a large puzzle. Imagine you have all the pieces, but some of them are invisible. That is what happens with dark matter. We cannot see it directly, but we know it is there because it affects what we can observe. Now let's say that quasars are one of those bright pieces of the puzzle. They are like beacons that illuminate our path, but they also give us clues about what is happening in the universe. Quasars, being extremely luminous and distant, allow us to study dark matter in a unique way. How? Through their light, which travels billions of years to reach us, telling us stories about the galaxies and structures of the universe in which they are found. As the light from a quasar travels through space, it can interact with the dark matter surrounding galaxies. This dark matter does not emit light, but its gravity acts like a magnet that affects the light from quasars. Thus, when we observe a quasar, we are not only seeing its direct light, but also how that light bends and distorts as it passes near dark matter. This phenomenon is known as gravitational lensing and is a powerful tool for astronomers. What does this tell us about dark matter? By studying these distortions, scientists can infer the amount and distribution of dark matter in the universe. Think of it as using a map to find hidden treasure. The light from quasars is like the clue that guides you to the location of this invisible treasure. In this way, quasars are not only objects of study in themselves, but also carriers of crucial information about the composition of the cosmos. The connection between quasars and dark matter also raises intriguing questions. Could it be that quasars are indicators of the presence of large concentrations of dark matter? Some scientists suggest that by observing a quasar, we might be seeing not only the light from the supermassive black hole that feeds it, but also the environment in which it exists, influenced by dark matter. This opens the door to new theories about how the universe forms and evolves. Moreover, dark matter plays a fundamental role in the formation of galaxies. Computational simulations suggest that without dark matter, galaxies would not have enough gravity to come together and form stable structures. Thus, quasars, being at the center of these galaxies, can be considered witnesses to this process. They are like beacons that illuminate not only us, but also the universe itself, showing us how it has been woven together over time. However, the relationship between quasars and dark matter does not end here. Some researchers are exploring the possibility that quasars could be used as tools to measure the expansion of the universe. By observing how the light from quasars is affected by dark matter over different periods of time, scientists can gain valuable insights into how the density of dark matter has changed throughout the history of the cosmos. Imagine that quasars are like lighthouses in an ocean of cosmic mysteries. As we navigate this ocean, quasars help us identify islands of dark matter and understand the currents that surround them. Each time a quasar is observed, it's like a light turning on in the darkness, revealing something new about what is around us. Despite advances in research, many enigmas remain. Why does dark matter seem to be so abundant in certain regions of the universe? And what role does it play in the life and death of quasars? Each answer we find generates new questions, making the research on quasars and dark matter an exciting and ever-evolving field. As we continue to explore this relationship, we may discover that quasars are not just objects of interest, but also keys to unlocking the secrets of the universe. Dark matter could be the thread that ties all elements of the cosmos together, and quasars could be the beacons that guide us through this immense web. In summary, the connection between quasars and dark matter is one of the most fascinating areas of modern astronomy. It invites us to reflect on our understanding of the universe and to question what we think we know. As we continue to investigate, we are likely to find new ways of seeing the cosmos, and quasars will remain protagonists in this ever-developing story. The next time you observe a quasar in the sky, think about all that it represents. It is not just a distant light, it is a reminder that the universe is a place full of mysteries and that each discovery brings us one step closer to unraveling its secrets. Dark matter and quasars are just two of the many elements that make up this wonderful cosmic adventure, and their study will help us better understand our place in the vast universe. Space missions have been fundamental in our quest to understand quasars, those mysterious beacons of the universe. Since their discovery, these objects have challenged astronomers to think beyond the known and explore new frontiers. But what missions have shed light on these enigmatic celestial bodies? One of the first notable missions was the Hubble Space Telescope, launched in 1990. This observatory has provided stunning images of quasars over the years. Can you imagine having an eye in space that can see billions of light years away? Hubble has allowed scientists to observe the light from quasars that formed in the early universe, providing a window into cosmic history. Through its powerful lenses, we have learned that some quasars are so bright they can outshine entire galaxies that host them. But Hubble hasn't been alone in the search. In 1994, the Rosette satellite mission, an X-ray telescope focused on detecting the light emitted by quasars at wavelengths that couldn't be seen with optical telescopes. This mission was key, as it revealed that many quasars emit a large amount of energy in the form of X-rays. Why is this important? Because it helps scientists better understand the nature of the energy they produce and how they relate to supermassive black holes at their centers. The Fermi Gamma Ray satellite, launched in 2009, has also been a great ally. Fermi has allowed us to explore the universe in a part of the electromagnetic spectrum that was previously poorly understood. Did you know that some quasars are very powerful sources of gamma rays? Fermi has provided data that have challenged existing theories, showing that quasars can emit more energy than previously thought. This has led to new questions about how this energy is produced and channeled. Each space mission has contributed fragments of information that help us piece together the puzzle of quasars. For example, the Kepler Space Telescope, known for its search for exoplanets, has also contributed to the study of quasars by observing changes in their brightness. But what does this mean? Variations in the light of a quasar can provide clues about its internal structure and the processes occurring near the central black hole. It's as if we are listening to a whisper from the universe that tells us secrets about its workings. But not everything is based on observations. Space missions have also conducted experiments and simulations to better understand the environment of quasars. With the help of supercomputers, scientists have been able to create models that simulate the behavior of matter around a supermassive black hole. Can you imagine recreating a mini-universe on a computer? These simulations allow researchers to observe how matter accelerates and heats up as it orbits the black hole, producing the energy that turns quasars into the cosmic titans they are. Some missions have also been specifically designed to search for quasars in the early universe. The Euclid mission, expected to launch in the near future, will focus on mapping the structure of the universe and studying how galaxies and quasars have formed over time. The question we ask is, what discoveries will Euclid reveal about quasars that we do not yet know? In the field of quasar research, international collaboration has also been key. Telescopes from around the world have come together to simultaneously observe quasars at different wavelengths. This has allowed scientists to gain a more complete view of these objects. Can you imagine a team of researchers from different countries, all looking at the same point in the sky, trying to unravel the mystery of a quasar? Each finding brings new questions. Each discovery about quasars not only helps us better understand these objects themselves, but also the universe as a whole. How do quasars influence galaxy formation? What do they tell us about the evolution of the cosmos? Each space mission adds another piece to the puzzle, helping us understand the crucial role that quasars play in the history of the universe. Space missions are not just a quest for information. They are an odyssey where human curiosity confronts the vastness of the universe. Through telescopes and satellites, we have managed to decipher part of the cosmic narrative surrounding quasars. These objects are like lighthouses, guiding us toward a greater understanding of the nature of space and time. The exploration of the universe does not stop here. As technology advances, so do our capabilities to observe quasars. With each new mission, we get a little closer to answering the deepest questions of cosmology. What mysteries will the next generation of telescopes and satellites reveal? The search continues, and with each discovery, the universe becomes a little more familiar, but also a little more complex, challenging us to keep seeking answers. Quasars are fascinating phenomena that have captured the imagination of astronomers and enthusiasts alike. But what happens when these cosmic beacons collide with black holes? The answer to this question is not only intriguing, but also offers us a window into one of the most spectacular and enigmatic events in the universe. Imagine a gigantic whirlpool of light and matter, where a quasar with its dazzling energy is engaged in a cosmic dance with a supermassive black hole. This interaction is not just a casual encounter. It is a spectacle of gravitational forces that can unleash a series of cataclysmic events. But what really happens when these two entities cross paths? When a quasar and a black hole come close, a phenomenon known as accretion is triggered. In this process, the black hole begins to attract the matter from the quasar, which is composed of hot gas and dust. This matter, as it approaches the black hole, forms a bright accretion disk that emits intense radiation. In fact, this process can be so powerful that it can outshine the light of billions of stars combined. But what does this mean for the cosmic environment? The energy released during these encounters is so immense that it can influence an entire galactic system. For example, the emitted radiation can heat the surrounding gas and in some cases even inhibit the formation of new stars. This is crucial for understanding how quasars affect the galaxies in which they reside. But how does this relate to the life of quasars? As a quasar consumes the surrounding matter, its brightness can vary dramatically. This flickering light is not only fascinating from a visual standpoint, but also provides clues to astronomers about the nature of the quasar and its black hole. Have you ever wondered how scientists can measure these changes and what information they can glean from them? Astronomers use powerful telescopes and sophisticated observation techniques to study these events. By analyzing the light emitted by the quasar before and after its encounter with the black hole, they can gather information about the speed of the material being consumed and the amount of energy being released. But what implications does this have for our understanding of the universe? Each collision between a quasar and a black hole provides valuable data that can help scientists better understand the evolution of galaxies and the dynamics of the cosmos. These events are like open books, each revealing a chapter of the universe's history. However, the questions do not stop there. Could the encounter between a quasar and a black hole give rise to the formation of new quasars? The possibility is intriguing. When a black hole consumes a large amount of matter, its growth can be explosive, which in turn can lead to the formation of a new quasar. This cycle of birth and death of quasars prompts us to reflect on the cyclical nature of the universe. What other secrets might be revealed through the observation of these encounters? As astronomers continue to investigate, technology advances, allowing us to observe events that were previously invisible. For example, next-generation telescopes are designed to capture the light of quasars at different wavelengths, providing a more complete picture of what occurs during these encounters. What will be the next revelations about the behavior of quasars and black holes? Collisions between quasars and black holes are not just a visual spectacle, they are also crucial for understanding dark matter. As these phenomena release energy and matter, they can offer clues about the composition of the universe. To what extent can these events help us unravel the mystery of the dark matter that seems to make up most of the cosmos? The complexity of these interactions reminds us that the universe is a place full of surprises. As scientists unravel the secrets of quasars and black holes, each discovery opens up new questions and possibilities. What new theories will emerge from the study of these extreme phenomena as progress is made in this field? Quasars continue to be a vibrant and promising area of study. The collision between a quasar and a black hole is not just an isolated event, it is a key to unlocking the mysteries of the universe and gaining a better understanding of the fabric of the cosmos. What other types of cosmic phenomena might be lurking in the darkness, waiting to be discovered? Quasars and colliding black holes serve as a powerful reminder of the grandeur of the universe and our innate curiosity. Through exploration and discovery, we continue to seek answers to the questions that have intrigued us for centuries. What other wonders await us in the depths of space and time? Quasars are like beacons in the vastness of the cosmos, illuminating our understanding of the universe. But what makes them so special? Today, quasars are not only fascinating, but also crucial for our comprehension of modern astronomy. As we explore the vast fabric of space, quasars emerge as powerful tools that help us unravel the secrets of the universe. First, let's consider their role in galaxy formation. As astronomers observe distant quasars, they realize that these objects are not just bright points in the sky. They are witnesses to galactic evolution. When a quasar shines brightly, it often indicates that it is feeding a supermassive black hole at the center of a galaxy. This interaction can influence star formation and the growth of the galaxy itself. Imagine a lighthouse that not only guides ships but also helps create new lands. It's not just their brightness that captures attention. The light from quasars can tell us stories about the universe. Through their spectrum, scientists can analyze the chemical composition of the surrounding medium. This allows us to understand how elements were formed in the cosmos and their distribution in space. What secrets does the light of a quasar hold? The answer lies in the atoms and molecules that shine in its spectrum, revealing the history of its environment. Moreover, quasars are fundamental for measuring distances in the universe. How do we know how far away they are? Through the relationship between their brightness and distance, astronomers can use quasars as cosmic scales. This not only helps to understand the structure of the universe, but also provides clues about its expansion. Just as a traveler uses lighthouses to navigate unknown waters, scientists use quasars to map the vast ocean of space. In the context of dark matter, quasars also play an intriguing role. There are theories suggesting that dark matter, that mysterious substance we cannot see, could influence the formation and behavior of quasars. Could it be that these beacons of the universe are in some way guided or fed by forces we do not yet fully understand? The answer to this question could change our view of the cosmos. The connection between quasars and black holes also highlights their importance. When a black hole devours matter, an immense amount of energy is released, turning the quasar into an extremely bright object. This not only allows the observation of these distant phenomena, but also provides information about the nature of black holes. What happens at the boundary between a quasar and a black hole? That interaction is a fascinating field of study. Quasars have also been protagonists in the search for life elsewhere in the universe. By studying how quasars behave, scientists can deduce conditions that might be favorable for life in other galaxies. In this sense, quasars are like lessons from the past that could guide us in our search for life beyond Earth. Technology has also advanced thanks to the study of quasars. As we develop better instruments to observe these objects, more powerful and precise telescopes have been created. These advancements not only apply to the study of quasars, but also benefit all of astronomy. Who would have thought that studying a quasar could lead us to discover more about our own home in the universe? Quasars continue to be an active area of research. New space missions are specifically designed to study these objects. With each discovery, our understanding of the cosmos expands and new questions arise. What mysteries still await us in the vast universe? Quasars remind us that despite what we have already learned, there is much more to explore. As scientists delve deeper into the study of quasars, they are also discovering more about time itself. The light from quasars allows us to observe the universe as it was in the past. Each flash of light is like an echo of lost eras, allowing us to look back in the history of the universe. What stories do those echoes of light tell? Quasars, in their essence, are like a bridge between the present and the past, and between the microcosm of our solar system and the macrocosm of the universe. They become beacons that illuminate not only space, but also our knowledge and curiosity. With each new discovery, quasars challenge our imagination and drive us to keep exploring. Finally, the importance of quasars in modern astronomy cannot be overstated. They are more than just bright objects. They are tools that help us unravel the secrets of the universe. From galaxy formation to the evolution of the cosmos, quasars guide us in our quest to understand our place in the vast and mysterious universe. Each answer we find leads us to new questions, and each quasar we observe is a reminder that there is always more to discover. Quasars are like cosmic beacons illuminating the vast ocean of the universe, but what questions do we still have to answer about them? As scientists continue their research, new doors to knowledge are opening. For example, how do quasars affect galaxy formation in the early universe? This is one of the many questions astronomers are asking today. By studying the intense radiation from quasars, we can better understand how galaxies developed and how the universe has evolved over billions of years. Technology is advancing rapidly, and with it, the way we observe these cosmic phenomena. Next-generation telescopes like the James Webb Space Telescope are allowing researchers to look further back in time than ever before. What surprising discoveries will this new era of exploration bring us? Each observation gives us a glimpse into the past, revealing quasars that existed when the universe was still young. It's as if we have a time machine that allows us to see how all the matter around us was formed. But it's not just about observing. The interpretation of the collected data is equally crucial. For example, by analyzing the light emitted by a quasar, scientists can identify the composition of elements in its environment. What secrets will this light reveal about the formation of elements in the universe? By better understanding how these elements are created and distributed, we can gain insights into the history of our own galaxy. The Milky Way. It's a cosmic puzzle that astronomers are eager to solve. Moreover, quasars provide a fertile ground for theories about dark matter and dark energy, those mysteries that still elude us. Could quasars be the key to unraveling the role of dark matter in the structure of the universe? As researchers delve into these topics, they may find unexpected connections that transform our understanding of the cosmos. We cannot overlook the importance of international collaboration in quasar research. Astronomers from around the world are working together, sharing data and observations to build a more complete picture. What synergies could arise from these collaborations? The union of diverse perspectives and ideas can lead to discoveries that a single group could not achieve. Science is a collective effort, and quasars are the perfect ground for this collaboration to flourish. As we explore the future of quasar research, we must also consider the impact of artificial intelligence on data analysis. With the massive amount of information generated, AI can play a crucial role in identifying patterns and anomalies. Could artificial intelligence help us discover new quasars that we have not yet observed? The combination of astrophysics and cutting-edge technology promises to revolutionize our understanding of the universe. Education and scientific outreach are also crucial in this journey. Effectively communicating our findings to the public is essential for maintaining interest in astronomy. How can we inspire future generations to continue exploring the mysteries of the cosmos? By sharing captivating stories about quasars and their influence on the universe, we can motivate young scientists to join this exciting quest for knowledge. On the other hand, research on quasars also has implications for the search for life elsewhere in the universe. If quasars influence galaxy formation, could they also provide favorable conditions for the emergence of life? This interconnection between quasars and the possibility of life leads us to reflect on our place in the cosmos and the nature of existence itself. Let's not forget that quasars can be indicators of broader phenomena, such as the expansion of the universe. The way they interact with other astronomical objects could provide us with clues about the nature of dark energy. Could these cosmic beacons be the keys to understanding how the universe behaves on a large scale? The quest for answers to these questions is not only exciting but also fundamental to our understanding of the cosmos. Finally, as we move toward a new era of discoveries, it is important to maintain curiosity and imagination. Quasars are just one part of the vast puzzle of the universe, but their study pushes us to keep exploring. What wonders await us on the horizon? Quasar research is far from over. With each new generation of telescopes and each advancement in technology, we are closer to unveiling the secrets that the universe has in store for us. In conclusion, the future of quasar research is bright and full of potential. The questions that remain unanswered are countless, and each discovery brings us a little closer to understanding our existence and that of the universe as a whole. The exploration of these cosmic beacons not only enlightens us about the past, but also guides us toward the future. The adventure is just beginning. Quasars, those extraordinary lights of the cosmos, have taught us so much about the nature of the universe. What are they really? These powerful sources of energy, billions of light years away, not only illuminate our night sky, but also shed light on our understanding of the past and future of space. In this fascinating journey, we explore how quasars act as beacons in the darkness of the universe, revealing secrets that would otherwise remain hidden. When looking up at the sky, one might wonder, why are quasars so important? The answer lies in their ability to tell us about the history of the cosmos. Imagine each quasar as a time capsule, sending its light through the vast emptiness of space. This light can be an echo from times when the universe was young and chaotic, allowing us to glimpse how the first galaxies formed and how our own home in the cosmos evolved. The energy they release is, in many ways, a mystery. Although we know that quasars are powered by supermassive black holes, the dynamics that lead to their formation and brilliance are complex. What makes a quasar so powerful? They are generating energy at an astonishing rate, and in their core, the material falling into the black hole produces an explosion of light and radiation. This process is like a cosmic dance where chaos turns into light, and that light can be observed even from Earth. In the quest for knowledge, quasars also help us better understand the structure of the universe. Have you ever thought about how galaxies form? Quasars play a crucial role in this process, acting as catalysts that influence their surroundings. By releasing enormous amounts of energy, they can affect the formation of new stars and the evolution of galactic matter. These interactions are fundamental to understanding how the fabric of the universe we know today has been woven. When talking about quasars, we cannot overlook their relationship with black holes. These invisible giants are fundamental in the history of quasars, as each quasar is located at the heart of a galaxy, where a supermassive black hole resides. The connection between the two is like an epic tale of power and light, where the black hole feeds the quasar and in turn the quasar illuminates the universe. This relationship is a reminder of how interconnected all elements of the cosmos are. Research on quasars is exciting and continues to reveal new discoveries. The light they emit is not only bright, but also contains valuable information about their composition and the environment surrounding them. What secrets is that light telling us? Each photon traveling through space is a piece of the cosmic puzzle, and scientists are tirelessly working to decipher its message. As we look to the future, what does the study of quasars hold for us? Space missions are designed to delve deeper into these mysteries. With increasingly advanced telescopes, the exploration of quasars is becoming a vibrant field of astronomy. Could we discover new classes of quasars or unravel phenomena we have yet to imagine? Human curiosity knows no bounds, and each answer brings new questions. Throughout the centuries, quasars have captured our imagination, not only in science but also in popular culture, from movies to books. Their presence has inspired generations. This cosmic phenomenon has been interpreted in multiple ways, reflecting our own quest for understanding in a vast and often bewildering universe. How do these scientific concepts transform into narratives that resonate with the public? Science and art are more than ever intertwined. Reflecting on the importance of quasars, it is vital to remember that each one is a testament to the history of the universe. They offer us a window into the past, revealing not only the evolution of galaxies but also that of the cosmos itself. How far can we go in our understanding of these bright lights? Perhaps in our attempt to unravel their secrets, we will discover details about the very nature of time and space. In conclusion, quasars are much more than mere points of light in the sky. They are beacons that illuminate the path toward understanding the universe, revealing secrets and challenging our imagination. As we advance in our exploration, each discovery brings us a little closer to unveiling the mystery of the cosmos. So let us keep our eyes on the sky and our hearts open to what is yet to come, the adventure of understanding quasars. And thus our universe is just beginning.